am the mechanical seal and reliability engineer with Seaward Equipment, and today we're going to cover mechanical seal piping plans. First, one of the things you want to understand before we actually talk about the flush systems is understanding that mechanical seals have requirements that they need to in order to run properly. With liquid seals, you want to be able to provide the seal with a stable fluid, a fluid that has good lubricating properties, fluids that won't flash in the seal chamber, fluids that are free from contamination and solids, and ones that have moderate viscosities. Viscosity is one of those things that is actually sometimes glassed over when doing seal applications. Everybody tends to focus in on specific gravity, but viscosity is a very, very important part. Viscosities can cause a lot of viscous shear, and they won't allow a lot of proper lubrication. So flush systems help out in the areas where you have very, very viscous fluids. For gas seals, you want to make sure that you have very stable vapor sealing gas, a constant supply of external barrier gas, and that is a very, very key component. Often a customer will want a gas seal in an application because it fits, but they don't have any way of generating gas. They don't have a nitrogen generation, or if in a case where you can use air, maybe don't have enough air capacity with the compressors. If you're limited to bottle banks, what can happen with bottle banks is, of course, they can be depleted. You have to constantly maintain them. You have to constantly sometimes shuffle the bottles. It can be a real problem. And so if you don't have a constant supply, a reliable, dependable, constant supply of gas, it will cause more trouble than it's worth. You want to make sure that the process fluids are free from contamination, so very, very clean gas, nice and dry, filtered if possible. Process fluids which are not adversely affected by the gas, process fluids that are not adversely affected by the gas leakage. You don't want to have any reactions in your pump. Now, the purposes of piping plans. What you're doing when you add a piping plan of any sort is you're creating a more favorable environment for which the mechanical seal can run in. The flushing, they removes heat. It lowers the fluid's temperature. You alter the seal chamber pressures, which can, increase the vapor point so that you don't have any flashing. It cleans the process fluid out if you have lots of solids, and you get to, and in some situations, you actually, with flush plans, this is something that some people don't realize, is you can actually control the atmospheric side of the mechanical seal, which is also very advantageous. Some of the other features which are more oriented towards the dual seals is you can capture or prevent leakage, detect the leakage, which is important. You can route any leakage or any to appropriate collection and disposal areas. And you can also provide other fluids into the process that give for a much better sealing environment. Now, methods of achieving these goals. You want to make sure your piping or routing of the process fluids is proper. You in some cases want to introduce an external fluid into the system. You want to make sure you apply the proper auxiliary equipment. That's equipment that is off of the seal. Seal coolers, reservoirs, also known as seal pots, if you've heard that term before. And of course, there are added options and instrumentation that can be used to help you monitor the condition of your mechanical seal. Piping plans are standardized in a variety of categories, as you can see here, API, ISO, and they are designated by individual numbers. You'll hear quite often, as we talked about it just a little while ago, you'll hear someone say, what kind of flush are you running? And someone will say, I'm running a plan 11. I'm running a plan 32. Those are API designated terms that they've called out and defined as a type of orientation for the mechanical seal flush. ASME and the ANSI applications put a 73 in front of that API plan number. So you may also hear, what's the flush plan? You say it's an API 7, or excuse me, an ANSI 7311. That's the exact same as an API plan 11. Something to note. Now we're going to talk about single seal flush plans. Okay, one of the basics is the plan 2. This is simply a dead-ended seal chamber with absolutely no flush. In general industry, water services, sewer, very low temperatures, you'll see a plan 2. In more complicated services, where you might see in refinement, some chemical plants, you won't see that many plan 2s. But plan 2s are a very, very basic seal design. They're extremely simple. As I said, there's no environmental controls. You put it in, the seal is lubricated and runs in the process fluid. This is where they're used with large bore or open throat seals in moderate temperatures with clean fluids, and a lot of times used on top entry mixers and dry and agitators with a dry seal, because there are applications out there where you have I need a seal with that runs on a pocket of air. The plan 11, now this is a very common flush plan, and as you can see, here's the default single seal flush plan. This is used in, a lot in refineries, chemical plants, larger industrial applications where you have lots of heat. You'll see this is the default single seal flush plan. Some some plants actually require, they won't allow a plan 2. You have to have at least some sort of external flush, and the plan 11 is it. Very simple. It's a seal flush from the discharge of the pump into the seal through an orifice. The orifice is very important. The orifice allows you to control the amount of flow that you have going into the seal system itself. You want to make sure that if it's too much flow, the velocities are too high, it'll actually cause turbulence inside the seal chamber right near the seal, and that is not favorable for good reliability. It can move it around and it can cause a failure. So you want to be able to slow the fluid down. Generally, it's always a general rule of thumb, if you will. Figure just about 3/4 of a GPM of flow for every inch of shaft diameter that you have. If you just needed to run a quick calculation in your head and you weren't sure, that's something that you can do to figure out what type of flow you should have into your seal. Flush plans, when you get your when you have your seal selection done and you have the application done, flush systems and flush plans, that information is given to you at the time the application is done. So if they were to make a selection for a mechanical seal, they would say, this is the mechanical seal, and you want to have this flush plan, and you want to use this size orifice to achieve this flow rate. Those are the things that you should hear. If by chance you're dealing with any other seal vendor and you don't get that, ask a question. It's very, very important. Why do you use the plan 11? Well, you want to remove seal chamber heat. As the seal is rotating inside the pump, it generates heat. If you had a plan 2 with a closed box and there wasn't anywhere for the fluid to exchange and cool, it would just keep building up heat inside that box. The plan 11 allows for a constant flush of the process fluid into the seal chamber to flush away all that heat. It allows for seal chamber venting on horizontal pumps. Key word there is horizontal pumps. And a plan 11 also can be used to increase the pressure in the seal chamber to suppress the vapor margin. It won't allow the fluid to flash. These are used, general applications in clean fluids. You want to have a clean fluid. One of the key factors with a clean fluid is if you're running a dirty or abrasive fluid into a Plan 11, as you could see from the diagram, you'd be spraying or sandblasting a stream of fluid right at the seal, and eventually it'll just fail. And of course, you want to use non-polymerizing fluids. Polymerizing fluids have a tendency, they bond to everything. They're great for bearings, not so great for mechanical seals. All right, the next seal plan is the Plan 13. And you can see here, the Plan 13, instead of coming out of the discharge, well, now the fluid flow is coming out of the mechanical seal and going into the suction. Okay, so it's kind of like recirculation. Again, you want to use an orifice, and this is a standard flush plan on all vertical pumps. Now, if you can imagine this pump right here, which is in a horizontal orientation that you're looking at in the diagram. Now, flip it vertically. The high point, or where the air bubble or air pocket is going to form, is at the top of the pump, which is where the seal is. With a Plan 13, since you have differential pressure, the pressure of the suction should be lower than the pressure in the stuffing box. You will get a natural automatic venting process as soon as you start the pump. As you can see here, why do we use it? Continuous seal chamber venting. Seal chamber heat removal, just like the Plan 11. And an interesting thing that the Plan 13 does is solids removal. Now, this is one thing I want you to note. If you have an application that has some moderate solids, the Plan 13 is an excellent way to remove them. And I'll explain how. The natural action of the mechanical seal spinning acts kind of like a centrifuge and pushes the solids out away from the seal and towards the walls of the stuffing box. If you have a draw from the Plan 13, it's pulling these solids out and away and back into suction. It's a natural, action that the Plan 13 does. Again, you want to use these on vertical pumps. You definitely want to make sure that the seal chamber pressure is greater than suction pressure. Some pumps, especially double suction pumps, that is not the case. You can't use a Plan 13. But you want to make sure that your seal chamber pressure is greater than your suction pressure. Otherwise, you will not have flow. This is good to use in moderate temperature fluids with moderate solids. You can, like I said, if you have solids, and you can't do anything besides a process flush, you want to use the Plan 13. And again, non-polymerizing fluids. Now the Plan 14, an interesting application. The Plan 14, very simple. It's the combination of the Plan 11 and the Plan 13 we just talked about. What this allows you to do is basically you get twofold things that happen in this situation. You get continuous seal chamber venting on a vertical pump. So you get that automatic venting from the Plan 13. You'll get seal chamber heat removal, which you'll get from both the 13 and the 11. But now you can also add the increased seal chamber pressure to suppress the vapor point by using the Plan 11. So again, the Plan 14 is a combination of the Plan 11 and the Plan 13. And this is why it's used. This is used quite often in older refineries with the older style vertical pumps. Some of the pump styles are called the Union VLKs. They were very, very popular. You're pumping a light hydrocarbon. You need to suppress the vapor point, but you've got lots of pipe scale and debris that's actually floating around in that system. You want to be able to keep that away from the seal faces, and this is one way of doing it. Again, vertical seals, clean, but again, you get the added benefit of the Plan 13, non-polymerizing fluids in moderate temperature. Now, what do you do when you've got lots of heat? and this is one of my favorites, is the Plan 23. Plan 23s generally fix a lot of problems when you have high heat. And what basically is happening here is you have your process fluid that's inside the stuffing box is exchanged from the seal to a cooler and then back to the seal. It's done with a small pumping device that's actually on the rotating piece of the mechanical seal. It's called a pumping ring. You'll hear that referred to. It's a pumping ring. All a pumping ring is, it's a little tiny device with small notches in there, steps, looks almost like a gear, and as it spins, it naturally circulates the fluid in and out of the seal chamber. This is a standard flush plan and hot water services. Key word there is hot water services. Hot water, when it approaches, I'd say above 170 degrees, starts to lose a lot of its lubricating properties. Even though it hasn't quite, again, it's not boiling. You're starting to lose a lot of the lubricating properties. You want to be able to, cool that water down and get those lubricating properties back in your system. Now these are efficient ways of cooling the fluids. Okay, they increase the vapor margin because you're cooling the fluid down, and it improves the water lubricity, again, because you're cooling the water down, or any fluid for that matter. Okay, where you use it? High temperature services with hot hydrocarbons are very often at hot hydrocarbons. Sometimes you have hot hydrocarbons in the 400 and 500 degree range. You can cool that seal chamber down and cool that environment down, and you all of a sudden give yourself a tremendous amount of reliability in your seal. Boiler feed applications, now here it states 180. That's the limit. I mean, you probably should start looking at something for seal coolers right at about 100 and I'd say 150, 60 degrees if you have applications, or 160, 170 degrees. You want to start looking at it. 180, definitely. That's the absolute limit. You don't want to go any. You want to have a seal cooler if you're going to be hotter than that. Again, these have to be very clean fluids. Because you are using a heat exchanger, you can get fouling. So non-polymerizing fluids are really important here. And you also have to be careful with the types of fluids, making sure that they don't coke up and don't foul your heat exchanger. Of course, now this is a very common that you see in wastewaters. They'll have wastewater plants will have flush systems, simply because a lot of the original wastewater plants, a lot of those pumps had packing, and they required some sort of external seal flush or packing flush. The Plan 32 basically is just that. It's a seal flush from an external source. So it's something that you have at your plant that you're bringing into cool the seal and help lubricate and flush it. Plan 32s might be a say you have a plant water and it's been treated, you got a lot of it, and it's nice and cool, and you're like, well, I can pipe that back into my seal chamber and use that as a flush. That's where something like this is used. As you can see here, there's some components that are required for an external flush. You want to make sure you have a flow meter. You want to make sure that you have flow, and you also want to make sure that you have some sort of a control device, because you're not using an orifice. So you want to make sure you're controlling the flow into the seal. Again, adds for excellent seal chamber heat removal. The 32 is, since you are literally giving it a designer flush for your single mechanical seal, the heat removal is a very big key component in the 32. Again, you don't have to worry about processed solids in your pumped media affecting your seal, because you are flushing them away with some sort of external source. And of course, you can increase the seal chamber pressure simply by adjusting your if you have enough pressure on your seal flush system, by adjusting the pressure regulator. These are, Plan 32s are used a lot, just like it says here, dirty or contaminated fluids. Pulp and paper industry a lot. High temperature services. Again, if you have this available, you have a coolant fluid that's compatible with whatever you're pumping, it is a nice system to apply. And again, in situations where you have polymerizing or oxidizing fluids, this is where you use the Plan 32. Now, Plan 32 is one last thing about I can talk about in the Plan 32, since this is the last of the single seal applications for piping plans. A lot of times you'll hear individuals, they'll have a bank of pumps, let's say 20 of them, and they'll say, well, I've got a flush system from, like I said, a process, a plant water system. So I'm going to run seal flushes, Plan 32s, to all 20 of my pumps. That's all well and good, but what happens if you have an upset in the system downstream or upstream? Your flush plan would then all fail, and you would fail all 32 or all 20 of the pumps that you have tied into your flush plan 32. So it's one of those things that you want to understand, that if you do these banks or these headers of flush systems, that you have to be able to control what happens if you lose the flush system. So that's something to consider. A lot of times people want to make the systems very efficient and limit the amount of equipment and stuff they have to put on the skid. That's one thing. One of the design pitfalls you need to look out for is putting all your eggs in one basket. You know, having one system that controls everything. The other thing you can't do is, if you have leakage, you don't necessarily know where to monitor the leakage from. You know, if you're losing one pump is using more than the other one, you have to kind of do a little bit of, you have to do a little diagnosis to try to hunt down where you're losing fluid. So enough said about the Plan 32. Now we're going to talk about dual seals. Okay, the dual seal Plan 52. Now, as you can see here before with the single seals, what's in red is your process fluid, and what's in blue is what they refer to as a buffer or barrier fluid. The rule is a buffer fluid is unpressurized, a barrier fluid is pressurized. I personally refer to them all as barrier systems or barrier fluid, and then call the system pressurized or unpressurized. That saves some confusion, especially if you don't do this every day. So you will hear me refer to any fluid that's running in a dual system as the barrier fluid. The 52 is unpressurized. The 52 circulates the fluid in the dual this is in the section between the primary seal and the secondary seal. So it's in between the two mechanical seals. It acts as a collecting area, and it is circulated from the seal to the reservoir or seal pot, whichever you refer to it as. The seal reservoir itself has many options that you can put on them. It can be as simple as a tank, or it can have cooling coils inside it to add some additional cooling. They can also have level switches, level gauges, all sorts of options, pressure switches, pressure gauges. You can get extremely elaborate with your dual seal support system. And this is where they refer to as the auxiliaries. All dual seals require some sort, liquid dual seals require some sort of auxiliary system to run. The Plan 52, this is an unpressurized system, and it's designed specifically to collect leakage. It's a backup seal. It's a zero or very low process emission. There's no process contamination is allowed. So with the unpressurized system, again, you're not putting any of the barrier fluid into the process. Okay, so it's only used as a collection point. So the process fluid leaks back into the barrier fluid. One of the key things here when going to dual systems and going to with auxiliaries and reservoirs, if you have or you're plant is a part of a VOC program where they have to check for VOCs. And those that you don't know what a VOC is, volatile organic compounds. Every quarter, the EPA has requires that you do a route on anything that pumps a hydrocarbon or anything that falls under the VOC guidelines. And they have to check to make sure that you're not leaking. And each state has different rates. I know like in California it was 500 parts per million, and I think here in New York it's 1,000 parts per million is the measured leakage. If you have a dual system, and I'm not 100% positive about this in New York, and they might have changed the rule, but it used to be that if you had a dual system, you were exempt from the VOC readings because you had a collection device. That's also a key thing to understand about a flush plan system in case you were looking at an application with a pump that you know that is currently on a VOC route. By going to a dual seal, you can eliminate that, especially if you've had problems with this pump getting written up for VOC repairs. Because once you get a VOC VOC failure, you have a certain time frame before that you have to shut the pump down and repair it. So it can be advantageous by going to some of these dual seals with flush systems. Again, used with dual pressurized, light hydrocarbons, hazardous or toxic fluids, and of course with some heat transfer fluids. Now, as opposed to the Plan 52, which is unpressurized, the Plan 53A, and there is a B and C. The A is the most common, and you are now a pressurized barrier system. Okay, works just like the 52. You have the same seal pot, same options that you would have on it. You are circulating from the seal back to the seal pot, but now both the mechanical seals, the inboard seal, the outboard seal, that would be the primary and the secondary, are now running on the barrier fluid. Big advantages here is you get to pick which fluids that you want your seal to run in. So you get to design the environment that your seal is running into. Adds for the longest reliability out there for dual seals. The 53A is one of, for dual systems, this is one of my favorites. Where the 23, the 53 is for the single, this is for the double, the dual seal. You isolate the process fluids. So no matter what you're pumping, you may have the worst process fluids in the world. Your seal doesn't care because it's running on the barrier fluid. Zero emissions. There is no way. It's not designed to leak. It's not designed to collect anything. It's always pushing fluid in. Used with, again, used with dual pressurized seals. Great for light hydrocarbons. Excellent for hazardous or toxic fluids. And it's also very good for dirty and abrasive and polymerizing fluids. Again, you take a lot of that out of things. Also can be used for mixers and agitators where you have where it's vertical and there may be just air around the, a lot of times you get air pockets around it. Doesn't matter because the seal faces are running on the fluid that's inside the seal itself. They're in between the two mechanical seals. And of course you can use them on vacuum services. So there are a lot of advantages by running a Flush Plan 23A with a dual seal. One thing to note here is because you are consuming barrier fluid, they make a lot of options now where you can actually fill the seal pot while it's online. So while it's under pressure, all you really have to do is be able to pump it in to the seal chamber above what the seal chamber pressure is set at. So it's very easy, and it can be done online, and it's very easy. Sometimes they're very simple quick connects that they can put on and fill the system. You always want to have, because this is pressurized, you do always want to have some sort of pressurization device pushing on acting on the seal chamber. Generally, it's a nitrogen at a certain pressure that actually comes in, and you can see on the top of the seal pot, you see a yellow line with an arrow. excuse me, it's a yellow line with a black arrow that's right directly on the top. That's where the pressure is applied. Usually you set that pressure to 25 pounds, usually above whatever the process box pressure is, and let it go. And of course, just like the Plan 32, you can also have an external system for your dual seals, and that's called a Plan 54. Again, you have your own circulating system that you have set up. You just pipe it in off of a header and plug it into your seal. Same, very similar to the Plan 32. The only difference on the dual seals from the 52 and the 53 is the 54 does not have any pumping ring. There's no circulating device in it because you're literally pumping it in and pumping it back out. It accomplishes the same goals that the 53A would. It's a pressurized system, so you're always pushing fluid into the process. Again, you see here, the seal cannot induce any circulation, so you don't want to have any pumping ring in there. Again, used in the same type of applications that you'd see with a Plan 53, 53A or B or any of the pressurized systems. Again, the Plan 54 falls under the same category as the Plan 32. It is an external flush, so you want to make sure you watch how your system that you're using to flush your seals, what the condition of it is, how reliable is it. Okay, now the steam flush is an external flush system. This is the one that's actually on the atmospheric side. Okay, and it's called a Plan 62, again used with single seals. Okay, it's an external quench on the atmospheric side of the seal. Typically, it's used with steam, nitrogen, sometimes water. Now, if you see here, again, the process fluid is in red. You can see the mechanical seal with a separation between the red and the blue. The blue fluid is actually not in between two mechanical seals. That's a single seal, so it's actually on the atmospheric side. There's only a bushing that basically acts to kind of break down some of the pressure and leakage on the seal. On applications like this, you usually have a steam line coming in on the top and then a drain out the bottom, and they're all wide open. The drain goes right to a collection source someplace, whether it's a sump, a pit, or whatever. What the purpose of the 62 is you want to prevent solids buildup on the atmospheric side. Okay, look at a cryogenic service where you have you're pumping something that might be very cold, 50, 60, 70 below. You want to prevent icing on the backside of the seal, so you want to add a little bit of heat to prevent that icing, and you want to that'll act to both kind of heat up and flush away any icing. Just conversely, if you had a very, very hot hydrocarbon, let's say like asphalt or something that cokes up really bad as it leaks, you'd have that tarish debris inside, just inside the seal, right at the interface of the two faces. You apply this Plan 62 steam flush, and it will push away and wipe away a lot of that debris, and collect it and carry it on down to the drain. Again, used with single seals. This is really it's only used with single seals. It's used with oxidized fluids that coke, hot hydrocarbons, just like I mentioned, salting, things that salt. I forgot about that. A lot of crystallized fluids that salt, caustics, and of course, cold fluids less than 32 degrees Fahrenheit. Okay, now real quickly, I'm only going to hit on one of these, is the gas seals. A lot of times people think that gas seals are only used on compressors with gas. Well, there actually are pump seal applications that use gas. Where would you use a gas seal? Well, we'll get to that in a second. Okay. Plan 74 is a gas system. And believe it or not, I think of it this way. A Plan 74 is kind of like a Plan 32, except with gas. The 74 takes a gas stream. Again, a reliable source of gas. Almost all the time it's nitrogen. and you run it through a series of devices and run it into your seal. Now, unlike the barrier, the reservoirs, the seal pots that have options, you have to run on the gas systems. You have to actually have a lot of the stuff that you see in front of you here that are represented by little characters. You have to have a flow meter because you want to make sure that you're always flowing gas to that seal. You want to have a pressure regulator so that you can regulate the exact pressure that you need. And you almost always want some sort of device that tells you that the gas supply has failed to your seal. Because as soon as you lose gas to the mechanical seal, your mechanical seal will fail. Not necessarily catastrophic, but you would then have to plan, you definitely have to plan an outage to change out your seal because you won't be able to reestablish that gas seal back to it, or reestablish gas to make that seal run on gas again. Again, it's a pressurized system, so you're always pushing gas into your into the pump. Very, very low rates, but you are pushing gas in there, gas in there. Again, typically with nitrogen. One of the big advantages of nitrogen systems is, again, it's a zero emission seal. Very clean, very simple, and you isolate the process fluid from the outside world. Again, there are always dual seals. Gas seals are always all dual. They work great for, again, light hydrocarbons, fluids that have problems with vapor margin, very unstable fluids that you may be pumping, maybe in like a vacuum pump type of a situation where you have mixed phase, where it may be gas and sometimes sometimes it's liquid and gas. It's very wet gas. Those are areas where you definitely, it's not a compressor, but it's but you have very bad flash point. Hazardous or toxic fluids, and of course you want to also in any type of fluid that to any type of service that won't tolerate certain types of barrier fluids. If you can't have any type of, if there's no fluids that are really compatible with what you're pumping, you'd have to use a gas seal. With the gas seals, you definitely want to make sure you have a very clean system. They've come a long way with how clean the systems have to be. It used to be any dirts or contaminants would fail would hang up and fail a gas seal very quickly. They've come a long way with design, and now you're starting to see gas seals and pump systems that you normally wouldn't have seen just say 5 years ago. So you're going to see in the future more and more of these. And again, the Plan 74 is the pretty much the default for pump gas seal applications. Okay. Lastly, we have some system layouts. Okay, when applying an auxiliary, this is, for example, a Plan 23 orientation where you have a seal cooler. Okay, this is the Plan 23, as you recall, that was for the single seal with the seal cooler. You have to lay these things out so that they fit into a certain envelope, because if you don't, they will not work properly. Now, as you can see here, from the midline of the seal itself, you can be no more than about 3 feet out. That's the max. You probably the barrier system, the dual systems, it's a little bit long, a little bit more. It's closer to 4 feet, but with the singles, you might be able to get 4 feet out of it, but you definitely don't want to go any further than 4 feet. And also, you want to be above the center line of the pump, no more than 18 to 24 inches above the center line of the pump. You definitely can't be any higher. You could be slightly lower, but you definitely don't want to be above 24 inches. Now, some of the reasons why you do this, you always want to be able to promote proper flow into this the seal cooler and back out of the seal cooler. Remember, you just have a little tiny circulating device on the mechanical seal. It's not truly a pump. It's just a circulator. If you're too far away, you'll have too much resistance to fluid flow, and it will not exchange to the seal cooler. And some of the other things that you definitely want to look at is you want to minimize the line losses. So you don't want to have a lot of bends and a lot of 90s and a lot of elbows. A lot of times I've seen a seal system where these pipe fitters will put this in, and they'll make that flush plan look so pretty. It'll come up, it'll turn, it'll go down along a wall, it'll come up in here. Yeah, no. Uglier the better. You want it to go from that seal in the most direct, sweeping bend way it possibly can go from the seal to the cooler. Large diameter tubing. You definitely want to make sure you're no smaller than the size of the nominal pipe size of the seal itself. So if you've got a 1/2 inch seal flush port on a seal, you don't want to go any smaller than that. You can always go up, but you can't go down. You definitely want to make sure you have upward sloping lines so that you don't have any dead legs. You don't want to trap any air in the lines. You want to make sure you vent it properly. And also, again, long radius bends. You don't want to have a lot of interruptions. And you want to avoid isolation valves in the seal flush lines. Sometimes you'll see them say, well, it's a default. I have to put an isolation valve from the process. It's not a good idea here, because if you forget, it acts as a resistance. If you forget to open one, it'll just cause you more problems. And now for the dual system on the Plan 53A, you'll see here, very similar lineup. Again, you have the same height requirements. This one is extended for the to 4 feet away from the center line of the seal. Again, same things apply. Minimize the line loss. Large diameter tubing. Upward sloping lines. Okay, and lastly, what I wanted to talk about on this last slide is the other piping plans that aren't mentioned here, and there's a reason why. The Plan 21 and the Plan 31. Now, you will see these in service, but they are not commonly recommended anymore. So out in your plan, I'm going to show you these 2 slides, and I'm going to show you, and I'll explain why they're not used. And I'm sure some of you have seen these in your systems. The Plan 21. Plan 21 looks like this. It looks just like a 23 with a combination of a Plan 11. So what you're basically doing here is out of the discharge of the pump, you go into the seal cooler, out of the seal cooler, into the seal. One of the problem you have here is you're always taking a hot fluid, and you're continually cooling that hot fluid. It would be much more advantageous just to exchange a small area, just what's in the seal chamber itself, with the exchanger and cool that fluid down. It's much more efficient, and it's much easier to do than to constantly take hot fluid and cool it down. Over time, you will foul your cooler quicker, and it can cause numerous problems as you start to diminish your cooling capacities. Now, this was once done initially because they wanted to suppress vapor margin by increasing the pressure in the box. Well, if you understand if you understand the little something about boiling points, if you cool the fluid in the stuffing box, by cooling it, you simply suppress the vapor margin. So wouldn't it be more advantageous just to cool a small area and get that nice and cool so that it can't flash than to continuously cool hot fluid? And lastly, the Plan 31. Now, the Plan 31 uses a cyclone separator, and I will say without a shadow of a doubt that you will come across people in your plants, out in the field, out in the world, that will say the Plan 30, the cyclone separator is the best thing since sliced bread. It all depends on the application, and this is why it's not recommended that much today. Cyclone separators, as you can see here, require 3 factors to run. You have to have discharge. It takes discharge flow off from the discharge side of the pump, runs it into the cyclone separator, and a cyclone separator looks like a little tiny tornado inside. The heavier, dirtier fluid, which is the brown line, runs down back into suction, and the cleaner fluid runs out the top of the cyclone separator and runs into the seal. Okay, all well and good in theory. There are some factors you have to consider here. Number one, the differential pressures between all of those components all have to fit into a certain design parameter for the cyclone separator size that you're selecting. If you're out of the range, you lose efficiency. You will not get as much solids removal. Second, if you have very viscous fluids or very, very light solids, they will not drop out. Over time, the cyclone separator will wear out. So as soon as you put it in service, it works fine. Over time, it's slowly going to wear itself out. Now you have to check and make sure that the cyclone separator isn't failing, because otherwise it's worthless when they're out of spec. And I guess the one area where you see this mostly used, water and sand. You know, with water and sand, there are two properties that like to separate. Sand likes to drop out of water. But if you've got crude oil and very, very light, fine sand, it won't want to drop out. So that's why I don't recommend the Plan 31. That and a Plan 13, which is the one I was telling you about that goes from the seal itself back to suction. The Plan 13, again, I was telling you, had that natural centrifugal action by throwing the solids away. You will actually get the same action. You will get the same type of advantage by running a Plan 13 as you would by adding this Plan 31 cyclone separator. Again, they're not completely obsolete, but you definitely want to understand that when you apply cyclone separators, they have to be engineered specifically for your application, and know that they require maintenance, and they require observations. So, again, to review, why do you use flush plans? Okay, again, intended to create more favorable environments for the seal, collect and detect leakage. They are documented API, ASME, ISO standard codes. They may require auxiliary. You may require auxiliary equipment to run external source fluids, and these are imperative and necessary to improve the seal reliability. Okay, and at this point, I'll take some questions. Just have to bring up my questions bar here. I went a little longer than I intended. This one is there's a lot of flush plans. Let me hang on one second. Let me make this big and see if there's any questions. You should have a questions tab that you can type some questions in. Unfortunately, I can't hear everyone right now. If there's anything, go right ahead. I'll tell you what. While you're trying to type or think up your questions, I'll put up my contact information next. As you can see here, there's my name, my telephone number, and my email. Feel free at any time to call or email me with any questions, concerns. If you'd like me to visit your plant, let me know, and I can review anything. I offer some on-site training and whatnot.